So first, we're going to start about a quick introduction of the concept. We're going to go into the challenges, and then finally, we're going to talk about just this concept of standards and passive house in the context of the Global South. So first, like I said, we want to look at, well, the concept of standards and looking at what would work in this context. If in the first workshop, we talked about this project, the eco-village in Tanzania, and we measured our performance over 4 metrics. We did not make it to the passive house standard of 10% overheating over 25 degrees, but we did meet our own design target of not exceeding 28 degrees as much as possible, the adaptive comfort, and the PMV method when we implemented wind control. So generally, when we're designing in a hot, humid climate, and even in hot arid climates, you kind of have to decide, do you go the natural low-tech ventilation route, or do you have to go the high-tech air conditioning? Because, and particularly in the hot, humid climate, those two are 2 completely different routes. They're not very similar. In a hot, dry, they're a bit similar. The strategies are very the same. But we wanted to try looking at a hybrid approach. And that's part of what we're going to be talking about. So one of the first challenges of designing in the Global South, power cuts. It lasts so long. In Sudan, they last 8 hours, 3 times a week. And that's a long time. And you don't really understand the impact of a power cut until you experience it. It's so hot there that you don't want to think. You don't want to do anything. Life stops. Like even if your laptop is charged, you don't want to use it anymore because you're so tired. And this is a photo of a house I did some research in. And the occupant in this house, when there was a power cut, it would reach 40 degrees in there within an hour of turning off the air conditioner. And she only had that tiny little balcony to stay in. And that balcony is so close to that wall that is just radiating that heat. And it's at the same time, you can see just how high it is. So you're not getting any actual shade from the sun. And you're getting the heat coming back to you from that thermal mass behind you. So because of that, she opted to stay in that car over there. And she would stay there for hours with her toddler because her toddler would just not stop crying because of how hot the house is. So imagine if you designed a building that only works well when air conditioned, when mechanically ventilated, and then this happens 3 times a week, 8 hours a day. So it's not an intermittent problem. It's not something that might happen. It's something that is going to happen, and quite frequently. And that's a risk whenever you're designing in the Global South you have to consider. The other issue is that you have to consider, what about all the other buildings in the area that you're designing? So even if you're going to design a very highly efficient building, if everyone else around you is using natural ventilation and they're using just fans, which don't consume a lot of energy, your building is going to consume significantly more than they are. And that kind of feeds into your decision, do I air condition this building or not? So that's in the context of Tanzania in our project. The houses surrounding us, the area was all naturally ventilated. People were used to a natural way of living. So it made less sense of introducing a highly efficient enclosed air-conditioned building. But, for example, in my research project in Sudan, people were slapping on air conditioners to buildings that were not prepared for it. So they were very, very highly consumptive. So trying to achieve that highly efficient air-conditioned building would make more sense in that urban context in Sudan than it would, for example, in the rural context of Tanzania. And it's just that decision-making process that you have to go through when you're designing your building. What is the area surrounding me? So these are some of the houses in Tanzania. You can see they have a mix of both. The predominant is those lower classes, but we've also had recently some areas being knocked off and people building closed middle-class houses with air conditioners. But the problem is, again, they're just a normal house with an air conditioner. They're not designed to be air conditioned. That's kind of one of the problems. Another factor you really need to consider when choosing what model, how connected are the people to the outdoors in your context? So in this context of Tanzania and in the context of Sudan, people use public transport, which is not air-conditioned, as I can attest. Many schools and workplaces don't have air conditioners, and people have yards in their houses. So people interact a lot with their outdoor environment, and that's more so in rural areas than urban. In the urban area, they might have a car, it's more likely, so you have to kind of consider that. Now that comes into play in this example. So this is a Passivhaus building in Dubai. It was one of the first, and the occupants complaint 2.6 was too hot, which is the set point of that building, which is absolutely ridiculous that they're in a climate where it's 45 degrees outside and they're saying they can't tolerate the 226. And as someone who's lived in the Middle East, I understand why. In the Middle East, you stay in an air-conditioned villa, centrally air-conditioned. They set the set point at 18, and it will be absolutely freezing in the middle of summer, and you're covered in a very heavy, thick blanket. You go into your air-conditioned car, into your air-conditioned school or air-conditioned workplace. There would be weeks where I hadn't seen the sun or the outdoors, and most of the population has a vitamin D deficiency in the desert. So that's a different context to show you that not all cooling climates should be summed up together with a solution that works for all of them. Another very, very big problem is supply chain. So a lot of these countries, electricity is cheap. And even if it's not cheap, it's a lot cheaper than the imported materials, particularly insulation. So this was a study done in Sudan to see how economically feasible would it be to insulate. And what they found is after 15 millimeters, which is absolutely tiny and doesn't really make a big difference, your costs start getting up. It becomes less and less financially feasible. And to kind of put it into context, Passivhaus in very hot climates like in Sudan recommends up to 400 millimeters of insulation, and it becomes not feasible after 15. So you can imagine here that challenge that if you're going to say, okay, let's insulate, you have to be very selective of how much you can actually get and where is it going to be sourced? Is it going to be imported? Again, giving you that contrast so you can understand the idea a bit more. This is a Passivhaus in Qatar. So they built these two villas as the exact same everything, but one of them is how a standard way in Qatar it would be built, and the other one is a Passivhaus. And they found it reduced their consumption by 50%, even though it only cost 20% more. Now you might think, why is this? The reason is, well, in Qatar anyway, they import everything. So this is just importing something different, and that's why the cost wasn't a big difference. And but in that context as well, because they had to import a lot of stuff, and because electricity is very cheap in Qatar, when they tried to do a payback period, they found that payback period was 190 to 377 years. So getting energy savings was not going to be an incentive in this context either. It's just purely for environmental reasons. Another big problem is skilled labor issues. So there's a lot in these countries, skilled labor usually migrates out abroad. There's a lot of brain drain. And because of that, even just building a normal house is very challenging to build it in a good way. So let alone when you try and introduce something that requires a lot of technical sophistication, like for example, achieving airtightness. How realistically can you achieve that when the labor there just is not aware of it? And Andy is going to talk a little bit about the challenges we faced in Tanzania.
It all seems so easy now. Now I'm back. Clicker. Have I got slides with this one, or am I just remembering?
I don't have a slide yet.
Okay, challenges. Okay. So, for those of you who didn't come to the first workshop, the context is an eco-village, so it's a permaculture-based 30-acre site which incorporates orphan children living with house mothers in units of accommodation, learning growing skills and making skills and having a basic education. It's a Muslim community. The site includes wooded areas, composting areas, all the things you might expect from a little permaculture experiment, and a wildlife zone. And in fact, it's the source of water for local villages, so it involves sort of ponds, and it also has quite a lot of mosquitoes. So we were brought in by a charity based in Birmingham. Kamran here is the person who brought us in, and we were asked to look at the problems with the existing houses. So they were not badly designed, German architect designed homes, but they were failing in various respects, mainly physically with things like bats infesting the attic spaces and shitting through the ceilings, very unhealthy, things were falling apart. They probably weren't too bad in terms of being well ventilated. Things had been thought about, but they weren't quite working. They did suffer from overheating. The orientation wasn't great, the shading wasn't great. It comes from fairly obvious mistakes that have been made, although some things have been got right. So myself and Huda Elsherif took a fresh look at this. We did some looking around, found some good examples of what people had done, and applied that in principle and came up with a design. So that was relatively easy part of the project. But to cut a long story short, there were many things we wanted to try, and one of them was contemplating doing a Passivhaus. We spoke to the Passivhaus Institute about this, and we had a very interesting technical discussion as to why the Institute would not be prepared to let us take a particular approach, which didn't involve control air conditioning the whole building, insulating the whole building and air tightness and so on. For us, it was obvious, as Huda sort of confirmed when we met her, that it was not socio-economically possible to do that sort of thing in a rural Tanzanian environment. I mean, it was so obvious. Now, we could have pushed it and we could have done a unique first Passivhaus in Tanzania, but it really wouldn't have lasted very long. It wouldn't have worked properly. It would have been a nightmare. It's not something that felt scalable. So we adopted a different adaptive comfort model approach, which Huda will go on to talk about in more detail. In terms of challenges of implementing the design, kind of all the things that we see in Britain, sort of finding the right builder, the builder being reliable, communication issues with the builder, getting cost, confidence and surety, all of the normal things, but just all a bit more difficult in every respect, really. I won't go on too much about it, but I think you can probably imagine those sort of challenges. So we cut through some of those problems by meeting people where they were. If they're using pressed soil blocks or sandcrete blocks, that's what we'd use. Everyone was building with metal roofs, that's what we did. There was sawn timber of certain sizes available, so that's what we used. And that's the approach we took. In terms of realising the project, in the end, it was not a bad job. I think, Huda, you actually commented, how did you get such a good result? So it wasn't too bad. But we still have leaking water pipes built into the walls. We still have things that were built wrong and then built right and then built wrong again. Why did that happen? How did that happen? So there were challenges, more challenging than here, but we took a very simple approach and we cut out a lot of the complexity. So hopefully that's useful context.
Sorry, can I just add one? The other, sorry.
Give him the mic, yeah.
Quite often we communicate on Zoom or emails, but the preferred method of communication, especially in global South, is WhatsApp. Everything happens on WhatsApp, and so working with each other on WhatsApp, I think, was quite challenging, and making sure you have lots of communications. Having Zoom calls hardly ever work because of no signal. So it was an interesting project, trying to implement this over WhatsApp, and there's lots of learning from that too. Maybe requires its own study.
Yeah.
So yeah, the general point is saying we kept the design as simple as possible, but even that had some challenges with the builder and stuff. So you can imagine if you required a more complexity, more technological advancement. Yep, no problem. Okay, so we're going to talk about the third context, which is Passivhaus in the context of the Global South. So we wanted to see if we wanted to turn our project into a Passivhaus, what would it require? First of all, the cooling and dehumidification demand would be 87 kilowatt hours per meter squared, which is significantly higher than what it is for a heating climate, which is just 15. And that's because Passivhaus acknowledges that in these countries, you can't really do that with 15. It's a lot. And now consider this compared to how much it would be just using a fan. It's a very significant load because you're not only cooling, you're also dehumidifying. So specifically to change our building, if we wanted to achieve that Passivhaus, we'd have to add more insulation to the walls, roofs, and floors, which, as we mentioned, has that challenge of sourcing it, and also in the other workshop, Andy mentioned that also If we put it in the ceiling, there's the risk of bats and animals and stuff. So we're still trying to figure that. But we'll also have to use double glazing, and in our current design, we're not using any glass at all. We'd have to add cooling and dehumidification units. We'd have to use MEV. So we'd have to kind of completely transition into that air conditioning, because it's hard to, you can't run both modes at the same time. We'd have to increase the shading on the eastern and western walls even more, and we'd have to reduce the glazing area. I say glazing area, but we don't actually have glass. So then that becomes the question. What is the implication of introducing an air conditioner? And we kind of touched this on Dr. Roberts' lecture earlier, that people should have access to an air conditioner when it's really hot. It's a fundamental right to be comfortable, just as it is to heating. But the problem with air conditioning is that it has a lot of impact on the humans themselves. First of all is expectations. Once people start getting used to a significantly cooler temperature, they no longer are comfortable with higher temperatures. It becomes a problem, because then they become less resilient. If there's a heat wave, if there's a power cut, they're now used to a much smaller comfort zone, because that's what their body is constantly being exposed to. Another problem with the air conditioner, it encourages you to stay indoors. So you lose that connection with the outdoors. And all of these parts are fundamentally part of the adaptive thermal comfort model. You become that adaptive thermal comfort model, if you've seen from our first workshop, it has a very wide range of comfort. But to do that, first of all, you have to have a connection with the outdoors, because you have to experience those outdoor temperatures, and that's what makes your body ready to adapt to those changes. You physiologically change, your blood vessels change, your sweat rate, you kind of adapt. You lose that. Another part is introducing air conditioners it's a big leap, because it makes occupants reliant on the building to do the work for them. And a lot of adaptive behaviors are an integral part of communities and their behaviors. Like I mentioned in the first workshop, that in the village we used to sleep outdoors, and that was part of our daily routine. We'd spray the yard, we'd have a conversation, we'd clean in the yard, and then in the morning we'd bring the beds all back in, and in the midday we'd have a nap, because it's the highest point of the day. And so you open the windows, you close the windows, but the air conditioning reduces that interaction with the building to just one button. You just click it on, off. And that creates a reliance that is really, really hard to break off later on. So whenever an air conditioner is introduced, it has to be done carefully, which is the second point. You have to make sure that you do it in a way that keeps all those other systems in place, that people still have that connection with the outdoors, that people are still able to continue with their adaptive behaviors, that they're still able to interact with the building, that it becomes an aid, not a reliance, which is what we've been exploring in this project as well. We're looking at introducing air conditioners in the bedroom, but in a way that when they can use the air conditioner, they can turn it off and they can go back into the natural ventilation mode, that it's not mutually exclusive. These are some of the sources for about the impact of air conditioning on users and the impact on their health, on their comfort, on their resilience. So in the comfort of the global south, a lot of the time we can't really achieve a highly efficient building like a passive house. But at the same time, we kind of have to get out of that mentality of all or nothing. We have to be able to do something to improve people's lives. And we should think of sustainability not as black as white, but as a spectrum of possibilities. Wherever we can make an improvement, we should try. So right now, the way it is in a lot of African countries is you either have a naturally ventilated mud hut, traditional life, 100%, or you'll have very rich population living in like an AC Passivhaus. This is one, for example, in South Korea, where it's also a cooling climate, but it's still very, very hyper modern. So what we're talking about is, what about this middle ground? What about mixed mode buildings that are more accessible to a wider section of the population who can't afford that passive house, but also don't want to live in that mud hut that is fairly comfortable, but it can't be used because of social stigma, because it doesn't fit with their modern expectations. So we have to, it's like Dr. Robert said, we can't eliminate the air conditioner, we have to incorporate it, but we have to incorporate it in a way that is smart and methodical, not just adding it. So Passivhaus already acknowledges the challenges of retrofit. It created a separate standard EnerFit for retrofit buildings because it realized it's really hard to get a retrofit as good as a new build. And in the workshop yesterday, one of them mentioned that it's almost impossible in the house in the 1990s to get a really good air tightness. And Passivhaus also addresses the challenges of a cooling climate. Here you see the kilowatt cooling targets for different countries. And they're all cooling climates, but Passivhaus acknowledges that because of the differences, it has different allowances for each one. So Passivhaus generally has this understanding of the different challenges. And what we're trying to do here is, well, introduce what about the socio-economic restriction? How can it address mixed mode buildings that are trying to achieve sustainability that is not 100% Passivhaus, but also not a mud house building, somewhere in the middle? And that is the project that me and Andrew are working on. Thank you for listening. Any questions?